Jeff Bezos, CEO and founder of online retail giant Amazon, has told employees in a company-wide meeting that he's fascinated by the electrification of the car industry. Citing this interest as a key reason behind Amazon's $700 million investment in EV startup Rivian, the CEO told staff that in addition to electrification, he also sees an exciting future in the ride-sharing and connectivity aspects of the transforming industry. Want to know about it? Well, stay tuned to the video and watch the video till the end. Hello guys, welcome to Bezos Space. Hit the subscribe button and turn on the notifications to get new updates about Jeff Bezos. Hit the like button to show your support, and in today's video, we're going to talk about Jeff Bezos just exposed that the game-changing BYD blade battery will shut down the EV industry. So without any further ado, let's begin. In addition to its investment in Rivian, which hit the media spotlight late last year at the LA Auto Show with its rugged all-electric R1T pickup and R1S SUV concepts, Amazon has also injected considerable funds into another automotive startup, the self-driving car developer Aurora, leading a $350 million funding round in the autonomous tech startup that was announced in February. It seems that Bezos is making moves to claim a piece of the rapidly changing automotive industry. BYD Europe anticipates that its game-changing new blade battery marks the start of a new era of safety and performance for the electric vehicle industry in Europe. With the uptake for EVs across the continent beginning to gather pace, the blade battery's ultra-safe credentials set it apart from conventional lithium iron-phosphate battery technology, and BYD believes gives it a significant USP in the EV sector. While undergoing nail penetration tests, the blade battery emitted neither smoke nor fire after being penetrated, and its surface temperature only reached 30 to 60 degrees Celsius. Under the same conditions, a ternary lithium battery exceeded 500 degrees Celsius and violently burned, and while a conventional lithium iron-phosphate block battery did not openly emit flames or smoke, its surface temperature reached dangerous temperatures of 200 to 400 degrees Celsius. This implies that EVs equipped with the blade battery would be far less susceptible to catching fire even when they're severely damaged. The blade battery also passed other extreme test conditions, such as being crushed, bent, being heated in a furnace to 300 degrees Celsius, overcharged to 260%. None of these resulted in a fire or explosion. With a large surface area, heat can escape from cells quicker. This negates the need for the cooling systems typically used with EV batteries. BYD firm says that in recent years, EV manufacturers have been looking for an even greater range, and that this has resulted in an unreasonable pursuit of energy density in the battery industry. It's due to this unpractical focus on energy density that safety has been sidelined from power battery development, said a spokesperson. The firm's blade battery, in contrast, is being promoted with safety front and center. The single-cell battery of the blade battery is designed to be extremely compact, measuring 96 cm long, 9 cm wide, and 135 cm high. These single cells are then arranged in arrays and installed into blade-shaped battery packs. BYD engineers also cut the cubic capacity of the battery installation in half, leaving more room for car storage or other auxiliary equipment. This compact design, combined with best-in-class safety certifications, gives BYD a significant competitive advantage and, more importantly, represents a major step forward for the entire electric vehicle industry. The batteries in those EVs use NCM, or nickel cobalt manganese cathodes, explained Dr. John Chen, project manager of vehicle engineering at BYD's Northern California headquarters. With NCM, you can easily get a fire. Users of that chemistry have to put a lot of effort behind thermal management and safety, adding cost. In comparison, lithium iron phosphate has proven chemistry whose benefits were somewhat bypassed by the industry settling on lithium-ion cells dominated by NCM, experts note. Where LFP cells shine primarily is in their inherent stability, typically sacrificing some energy density versus NCM for resistance to thermal runways. At approximately 200 Wh per kg at the cell level, they're about 10 to 15% less energy dense than most NCM cells. Tesla's 2170s are rated at over 260 Wh per kg. LFP batteries are probably most notable for their positive safety profiles relative to other chemistries, noted research analyst Maria Chavez of Guidehouse Insights in a May 2021 report. The chemistries are generally thermally and chemically stable, plus the phosphate chemistry has been shown to offer a long lifetime, she stated. LFP batteries have demonstrated life cycles in excess of 10,000 cycles or millions of highway miles. They exhibit lower internal resistance than NCM types, enabling faster power delivery. For improved vehicle acceleration, the discharge voltage of LFP is very consistent. Strategically, their chemistry does not include cobalt or nickel, and the lack of those metals makes them inexpensive, with LFP costs under $100 per kilowatt hour in China. That cost advantage has prompted Tesla, Ford, and Volkswagen to announce a shift to LFP cathodes in order to move away from cobalt and nickel. This is both the ethical mining reasons as well as to offer significant cost reduction for some EV models that don't require high performance and plus 200-mile driving ranges that will be covered by high manganese content lithium battery chemistries with higher specific energy. Ford, however, has indicated that LFP cathodes may also end up in the batteries of its electric F-Series. Aside from its clear safety advantages, BYD's Blade battery also delivers on power output. For longevity, the Blade battery tops 1.2 million kilometers after 3,000 cycles of discharging, while headline performance figures for the Blade battery-powered BYD Tang include a single charge range of 505 kilometers NEDC and acceleration from 0 to 100 kilometers per hour in just 4.6 seconds. The BYD Tang's Blade battery installation recharges from 30 to 80% of full capacity in an impressively short 30 minutes with a DC power output of 110 kilowatts. The combination of safety, long life cycle, and extensive single charge range capability places the BYD Blade battery in a class of its own. He Long, vice president of BYD and chairman of FinDreams Battery Co. Limited, covered 4 distinct advantages of the Blade battery, including a high starting temperature for exothermic reactions, slow heat release and low heat generation, as well as its ability to not release oxygen during breakdowns or easily catch fire. In the past few years, many EV manufacturers have fallen into competition for ever greater cruising range. When the range becomes the prime factor to consider, this focus is then transferred to power battery makers, leading to unreasonable pursuits of energy density in the battery industry. It's due to this unpractical focus on energy density that safety has been sidelined from power battery development. BYD's Blade battery aims to bring battery safety back to the forefront, a redirection from the industry's tenuous focus on this crucial aspect. Today, many vehicle brands are in discussion with us about partnerships based on the technology of the Blade battery, said He Long. He added that BYD will gladly share and work with global partners to achieve mutually beneficial outcomes for all industry players. The Han EV, BYD's flagship sedan model slated for launch this June, will come equipped with the Blade battery. The new model will lead the brand's Dynasty family, boasting a cruising range of 605 kilometers and an acceleration of 0 to 100 kilometers per hour in just 3.9 seconds. The Blade batteries are produced at BYD's ultra-modern smart manufacturing plant in Chongqing, China, which has an annual capacity of 20 gigawatt-hour and costs 10 billion yuan, 1.3 billion EU. Only compared LCD production facilities have such stringent cleaning standards, properly controlled humidity levels, and a constant temperature of 25 degrees Celsius. The 2021 version of the BYD Tang SUV, which is manufactured for the Norwegian market, was the first vehicle to feature the Blade. BYD has reportedly also signed a contract with Toyota that will see the battery used in a China-only EV similar to the Corolla that the two firms are developing together. The car was enabled by BYD battery technology, a source told Reuters. It has more or less helped us resolve challenges we had faced in upcoming, with an affordable small electric sedan with a roomy interior. The new electric vehicle will reportedly be slightly bigger than the Toyota Corolla and sell for less than 200,000 yuan, $30,000, a Toyota spokesperson commented on the Reuters report. We don't comment on the future products. Now that we've come to the end of this video, I want to thank you for sticking with me, and I'd love to know what you think of it. Just comment down below. Also, if you like this video, make sure you like it and stay safe. Today's video is over, but if you want to see more, there's one on your screen right now, and there are a few more fun videos coming soon. I'll see you in the next video.